Good morning. We are the representatives from Patumthep Vidyakhan School. Prioritize the responsibility of presenting English oral presentation. We will be presenting our technological research project, Helmet Wearing Classifier System. The member of our research group consists of Kanchanaparan Purisut, Chimada Chaisari, and Chanundamani. Our research project advisor is Mr. Thanakit Chwesai.
Can you enlarge your presentation?
Let's start with introduction, statement and significance of the research project. Following
I don't see the slide. Oh, sorry.
Following the Land Traffic Act 2522 says the motorcycle driver and passenger must wear crash helmet for safeguarding while driving and traveling. However, the death ratio from road accident per 100,000 people in Thailand tends to increase from 2014 to 2018, and moreover, the discipline of Patumthep Vidyakhan School Article 4.3 coming to school and going home in vehicle category says the riders and the passengers must wear helmets, which against and decreased dangerous accidents. From the survey of motorcycle using and helmet wearing of Patumthep Vidyakhan students in 2019, it was revealed that of all students, there are 560 students who use motorcycle as a 14%. And of all students who use motorcycle, there are 553 students who wear helmets at 99%. Because of the large number of students, assigned teachers are unable to operate properly, causing a slow, great and crowded road. This is the reason why we apply image processing to reduce the workload, the time for verification, and also to facilitate the teachers and students. Objective: first, this project aims to improve the helmet wearing classifier system. Second, to study the efficiency of helmet wearing classifier system that can reduce the workload, time, and the chance of the occurrence of a crowded road. Expected result: first, it can verify students who wear helmets generally. Second, it has the 80%. The code, we verify from 6 o'clock to 8:30 o'clock. We verify two patterns of helmets are full face and half face. We verify for colors including pink, white, red, and black. We verify students who ride a motorcycle at a speed under 30 kilometers per hour. And lastly, we verify especially riders. Definition: helmet wearing classifier system is an equipment which has thinking process and discrimination which verifies students who wear helmets in Patumthep Vidyakhan School by using image processing. Helmet is an equipment designed to protect the human skull and dangers from the internal head injuries in both full face and half face, range from pink, white, red, and black. Expected benefits: first, it can be a substitute for human verification. Second, is it more precise, quicker, and less error than human. Lastly, it can be applied with all the appliances and can be improved for the use in an actual situation.
This is our research project simplified into a flowchart table. The helmet-wearing classifier starts by importing a frame from a real-time video camera to the system. Then it will be classified through the motorcycle detection model. If no detection is reported, it will reset and run the code through the next frame. If yes is reported, it will continue to the helmet-wearing classifier. Same goes for this model. If the helmet detection is valid, it will reset and run the new frame. But if it's invalid, it will proceed to the last model, the license plate module. After extracted the license plate area, it will be sent to the school department for the regulations the rider has violated. The first thing we done to program our helmet detection device is training our model, which includes these 3 steps below: preparing example images, creating the model, and testing the model. Example images are photos containing students with helmets and without helmets. entering the gates of Patumthep Vidyakhan School. The images are taken from a group of voluntary students. 80% of the photos are used for the training, and the 20% are used for the testing. One of the essential factors for training a model is a pre-trained model. We have chosen SSD MobileNet in order to train the model for a fast and an effective result. To start training, we label our example images into the interested area, then deposit them into the test and train folders. Train folder contain 80% of the labeled example images and 20% for the test folder. Then we initiate the training procedure for the AI by using the resources we have just created. After successfully created a model, total loss data, a graphical report of errors between the training process will be created. To determine the performance of the model, we can evaluate from the total loss data and an actual data, which will be testing on the images which the model has not seen before. After testing, we can tune the performance of our model by adding more example images trained for a longer period of time and use a higher quality pre-trained model.
Results and discussion. After testing from 47 frames import into the model testing, we can conclude that 68% of the results are correct, being able to classify correct, and another 32% are incorrect detection. Detect in an area where there is no helmet, and the device detect in a frame which contains no helmet. Clarify that the model can further be improved. Discussion. A helmet detecting device with image processing can further be improved its detection ability by turning the performance. Place memorization is a consideration for the future feature. The automatic score managing system manages the score of the students who is found to be the non-helmet wearers. The last future feature is to improve the usage of the device by being able to use anywhere. Conclusion. Our detection device can detect white, black, pink, and red helmet moving under the speed of 30 km per hour. With guess accuracy, it's verified faster than human and can reduce the number of teachers used in the process. However, the helmet detection device has limits, distance, speed, and the availability of colors. The distance the device can detect is merely 3 to 4 meters. The speed higher than 30 km per hour will disturb the detection stability. Some color cannot be detected since the variety of example photos and videos is limited. Suggestion. First suggestion, the device should be placed in a illuminated area with no direct light shining through the camera, so the device can operate properly. Last suggestion, it should be placed at an area where it can see the rear of the motorcycles passing in order to able to capture the license plates which belong to the target group. Thank you for your attention.